This is TWIS, This Week in Science, episode number 938, recorded on Wednesday, August 9th, 2023. What's so super about science? Hey everyone, I'm Dr. Kiki, and tonight on the show, we will fill your heads with superconductors, superchemistry, and crocodiles. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. The future of the world depends on the people of today. Not just this today, but all the todays. The todays of tomorrow, and even the todays that happened yesterday. The world didn't always depend on humans. There was a time when roles were reversed, when humans depended on the world for survival. Some refer to this as the good old days, when mankind confronted nature on a daily basis, and intestinal parasites were common. And while the good old days may be behind most humans of today, what comes next is very much up to them. Will the modern human, unaccustomed to hard work and self-sacrifice, rise to the challenge and reverse global warming? Or will the humans choose the path of immediate least resistance, opting to do nothing as the planet irrevocably changes into an inhospitable wasteland of never-ending storms and ever-increasing heat waves? I think we all know the answer. It will be okay, as long as we still have This Week in Science coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And a good science to you too, Justin, and everyone out there. Blair is not with us tonight, as she could be going into labor anytime soon, so we don't know when we will next see her on the program, but we will be sure to let you know how things are progressing and when a little baby is brought into this world. So we're wishing her well and hoping that all is going exactly as
New
she
human.
wants it to be. Yeah, new little human coming into the world. It's very exciting. We're so excited for Blair and for Brian, but the wait is on. That's what's happening right now. So it's Justin and me, like the good old days, for a while. So this week, we've got a great show ahead full of science. I have news about some potential superconductivity discovery, some
Sorry about that story, too.
Well, no, I think it's a little bit different, actually, but just follows along. It's a different kind of thing. Quantum superchemistry, the center of the Milky Way, and the memory of a butterfly. What did you bring, Justin?
Let's see. I have ocean currents are gonna stop doing their job. They're gonna quit. I have a story about room temperature ambient pressure superconductor discovery, maybe. A third lineage origin of modern humans, maybe.
It's a lot of maybes.
Why you should keep your babies away from crocodiles, and that humming sound might not be from the refrigerator. It could be the galaxy.
Somehow I want to put the theme song for Star Trek and the Love Boat together in my head. There's something going on there. I don't know why. It could be brilliant. But anyway.
You've just broken my brain.
You are welcome. Everyone, now you have a brain earworm that doesn't actually exist.
Yeah, that's could be trouble. Yeah.
All right. Well, we're going to jump into the show, and I would love to remind you all that if you're not yet subscribed, you can subscribe to our live streaming channels where we live stream on YouTube, Facebook, and Twitch every Wednesday night at approximately 8 p.m. Pacific time. And we are also on social medias. We're on Mastodon at TWIS Science over. It's the Universidon server. We are also, I don't know if we're on Twitter anymore. I don't know. The X, I'm not really sure. We're on Instagram, other places, but look for TWIS Science or TWIS or This Week in Science. Our website is twis.org if you need more information. Time for the science. All right, Justin, what's at the center of the Milky Way galaxy?
Giant black hole. Quasar.
Yes, there is a giant supermassive black hole known as Sagittarius A, little tiny star thing, that asterisk. Sagittarius A has a mass of about 4.2 million suns.
That's a lot.
Only 4.2 million of our suns.
That's
no
so
biggie
many.
D.
That's so many.
Yeah, and it's really close to us. In a sense, it's about 27,000 light years away. So, we can see it. We've been trying to peer through the dust and gas and get an image of what's going on there for a very long time. But we've pretty much confirmed that it is a supermassive black hole now. And it's only one of two that we have ever observed directly, M87 and Sagittarius A being the two that we've looked at. Now, we've been able to figure out how stars move around Sagittarius A in their orbits and the way that the gravitational effects of that mass of Sagittarius A impact the stars that orbit around this supermassive black hole. We've been looking at it for over 20 years now, very, very long time. And there is a big question, which is a lot of supermassive black holes are the result of mergers of black holes. And so is it possible that there's more than one black hole at the center of our Milky Way galaxy? Is it just Sagittarius A, or is it Sagittarius A and some friends?
How big was it? 4.2 million suns?
Yes.
Okay. So, if you have a tiny black hole, say something that's only got 100,000 Earth suns mass.
Maybe not going to make a big deal compared to how big the Sagittarius A effect is, right?
Well, you could easily see it as, because gravity is just gravity. It doesn't care if you're a planet or a black hole. So if you have smaller black holes, I could see them orbiting just like anything else.
Yeah. So it could be orbiting and also potentially somehow merging, but they're also, if they're big gravitational masses, then they could impact the orbits of those stars that we're looking at around Sagittarius A. And so some researchers just publishing in archive.org, so it's not peer-reviewed research yet, they looked at a star known as S2. It has one of the closest orbits to Sagittarius A. It goes around that supermassive black hole in about 16 years. So we've actually been looking long enough to see it make a complete orbit. And so these researchers were like, hey, is there any evidence of other gravitational impacts? So if there's more than one black hole that we haven't noticed yet, hanging out there in the center, it should have had an impact that we could have seen. And so they checked it out and they were like, all right, let's see if there's some kind of intermediate sized black hole that's around outside the orbit of S2, then it should have impacted it. They found no impact. So as of now, there is no other black hole at the center of our Milky Way galaxy.
Right.
So far, we have no evidence of of intermediate mass. There might be smaller mass black holes that we haven't seen yet, but that is yet up for study. And again, this is not peer-reviewed research, and it's only observing one particular star. So
Yeah.
we need to look more.
So it's kind of interesting because it takes it's basically the method that we use to discover some of the outer planets. Right?
Yes.
Here's an orbit. Something about the orbit doesn't make sense quite. What could explain it? Another planet further out could make this make sense. Okay. Yeah, maybe when you're circling a supermassive black hole, those little perturbations don't make as much of a difference. Maybe they're a little less obvious. I don't know.
But that's what they have to be working on in terms of the orbital distance, where the stars are. Is there a star? Is this a black hole that's far enough out that there are other stars in between them? Like, where are things happening within the Milky Way galaxy? But at this point in time, this particular study says there's not an intermediate mass black hole orbiting Sagittarius A. So far, Sagittarius A is alone as far as we can tell, but we don't know that for sure. So, of course, researchers will continue to look. But when we're looking at something like the center of our galaxy, we're looking at the past, right? 27,000 light years away. You have some news about the past, but on this planet, right?
Segue. Yeah, this is actually this is a bit of a rant that's been building for a while.
Thank you for the disclaimer.
There's a launch off point. Okay, so recent review of a partial skull and jawbone found in China has been in the news. It is widely being portrayed as a second or third, depending on how you consider, origin path of modern humans. It is not. I'll just say that. It's not a new third origin of current modern humans. Although it could be, sort of. Just not in a way that will satisfy the Chinese anthropology community or the Chinese government, inserting that Chinese people evolved separately from the rest of humanity.
Wait, is that what the story is saying?
No, that's not what the story is saying.
I mean, is that what the study is saying?
It's not explicitly what this study is saying, but it is a common theme in all archaic hominid finds in China, is that they get tied loosely in the Western version of the study to a separate lineage of the Chinese people. Closer to home, they say, oh, this hints at, and if they've published in Nature or something like this, oh, this hints at, this could mean, back home, they're like, here's evidence. We've proved it again. So this find is absolutely positively not going to place the origin of Chinese ancestor lineages anywhere outside of Africa, at least not entirely. But they might be a little bit right. So I'm skipping the actual story here. It's a 300,000-year-old hominin with an oddly shaped jaw that could look more current modern human-ish, although it lacks a chin, and all of the other features are archaic, Homo erectus-like features. And China has a lot of these. The headline that accompanies almost every new discovery in China, it's morphological analysis. These are kind of old, from kind of old to very old, 300,000, sometimes even older, years old. But they're always suggesting that there could have been another convergent evolution of humans from Homo erectus in China, that started in China. It's never backed up with genomics, but that's partly because these are so old. But anyway.
A lot of our archaeological and fossil evidence is morphologically based because we don't have that genetic yet. Yeah.
But the morphological interpretations, highlight this jaw feature, which seems slightly out of place for what they would expect from an archaic, even though everything else fits. So, look, China is the world's current oldest continuous civilization at around 4,000 years of people occupying land and building on a continuous past. But they're not that old. They haven't been there that long. Okay. Separate.
You're okay.
All right, launching point.
No rant. Okay.
So this has been the way. It's sort of like you've got the right word for a crossword puzzle for the question, but you don't have enough spaces to write it. Sort of what's been going on over there. They have tons of these Homo erectus finds showing some Homo erectus evolution pattern in Eastern Asia and China. So Homo erectus is considered to be the first human ancestor to have left Africa. From Africa to reach the Far East, all the way to the islands of Java and Indonesia. We know that Homo erectus was there. And Homo erectus may have survived in Southeast Asia until as recently as it was around 108, 110,000 years ago. It's pretty darn recent. So for a while now, something has been bugging me about the Denisovans, to the point where I no longer think Denisovans existed. Not in the way that we consider current modern humans or Neanderthals or even Homo erectus to have existed. The reason is the sort of proto-Neanderthals leave the Levant. They head north. They settle in the Caucasus. From there, they kind of get separated from North and South Caucasus. The ones to the north, they head west. That's their path of least resistance. They end up in Europe, where they are isolated from other humans for hundreds of thousands of years, and we have our classic Neanderthals. The southern group likely heads east, likely through northern Iran, into Asia. This group is what is thought to have split off and evolved into Denisovans, which later can meet up with Western Neanderthals and Denisovan cave and have a few hybrids here and there, right?
Right.
So, but I don't think that's what the Denisovans are anymore. I think what we're calling Denisovans is really late surviving Homo erectus Neanderthal hybrids. And that there isn't a good picture of an isolated Denisovan population separate from this merging event. And everything is braided stream, as we talked about many, many times on this show. Human hominin evolution is a series of some isolated evolution and then a conjoining, and then some isolated evolution and more conjoining, and there's a lot of sharing of what we've learned along the way in terms of genomes. But a lot of think what we're calling Denisovan DNA even may actually belong to Homo erectus, for whom we have no isolated, definable genome to compare to anything else yet. We don't have anything we say, this genome was derived from Homo erectus, and now we know what Homo erectus looked like. And so some of the reasons I've come to this is all the Denisovans we find seem to be hybrids with Neanderthal. Sure, that could happen, that should happen, but why is it like all of them? And almost no matter where we found this DNA. The next areas with the highest Denisovan DNA, Southeast Asia, Oceania, we have no Denisovan finds, fossil record-wise. But this is where you find the fossils of the late Homo erectus. This is where their last stand is where Denisovan DNA has the greatest signal. That sort of southern Denisovan. And sort of, then there's also the current modern humans in East Asia. They have higher percentages of Neanderthal DNA than the current modern humans of Europe. So there are no Neanderthal. We're not finding Neanderthal remains in the East, which means they could have, and this is the current theory, they could have had those intermingling, merging events take place, like somewhere in the Caucasus, humans leaving Africa or leaving the Levant, and then running into Neanderthals and intermixing, and then heading out east. But it's also possible that the Neanderthals had already headed out east, intermixed with Homo erectus, defined loosely in sliding scale as Denisovan, and then the current modern humans show up. Because one of our earliest out of Africa signs, we have the Australians, but we also have Oceania, and I think it's in Cambodia where they found a cave that they think was current modern human occupied about 80,000 years ago, which is suggesting that not following the sea line, but following rivers and through Asia could have gotten humans there. And if they got there and there's already Neanderthal DNA there to mingle with, as opposed to bringing it with them, could paint a very different picture. Anyway, it's easy to speculate the future finds will solve these puzzles, and if I wasn't a betting man, I'd be rich right now. But it looks to me like the evidence for Denisovan genomes is better explained by Homo erectus influence on Neanderthal hybrids than a separate sort of evolutionary divergence of a Neanderthal turning into a Denisovan and then having... And it would be a very confusing thing to look at, too, because we are also related to Homo erectus. This is more likely our ancestor. And that's when it starts to also get interesting.
But we need... The whole thing comes down to the fact that we are really just looking at morphological data, and we're looking at measurements of skulls, limited numbers of skulls, and we don't have we don't have enough genetic information that goes back far enough. And that's where our limitations are for the braided stream and for figuring out much more. I mean, we've got mutations and some genetic variants that seem like it's okay, we've got Denisovans over here, and we've got Homo erectus, we've got Neanderthals, and maybe some mystery Homo species that are out there. But
and that's what I think. And that's where I think the Homo erectus also comes in. I think some of that mystery archaic is going to be Homo erectus. But I think that some of that, there's also these weird signals. There's a signal from a Neanderthal in the cave where they found the Denisovans that suggests there was a current modern human around 300,000 or 400,000 years ago that admixed. Well, or current modern humans share some DNA with Homo erectus that didn't, right? That hasn't, didn't diverge with the Western, or didn't stay the same in the Western Neanderthal, which means that current modern human could also be a signal that's showing up in places within the Denisovan, especially if they have. Anyway, it's going to be really fascinating development to watch going into the future.
Yeah, we need more skulls.
The Chinese researchers might not be completely wrong, even though they're completely wrong and where they want it to be. And it's a problem whenever you have agenda, or whenever you're trying to use anthropology and archaeology to say something you want it to. The history of anthropology and archaeology has been built on proving everyone wrong about their origin stories. That's what it's done over and over and over again. Nobody's origin story actually matches the archaeological record, and this won't either. However, maybe a little bit of truth into that, and I'm starting to think the Denisovans never existed.
Wow. Okay. Big statements from Justin today, and we'll see where that goes. You have been right about some things in the past. And so you could be right about this as well.
Sometimes. That's a resounding vote of confidence. Well, You haven't always been wrong. Lightning is going to strike twice somewhere, doesn't it?
Sometimes it does. Okay. All right. Hello, chat room. Thank you for being here and chatting with us. I have a story about social distancing in trees. Not in people, but in trees. Why do trees end up distributed the way that they do? For a very long time, the idea behind the spatial distribution of trees has been seed dispersal. That you have pollen, you have seeds, you have animals who eat the seeds and then poop the seeds, and you got all the great, seed dispersal. And there's a certain distance away from a tree that researchers have expected this seed dispersal to work. However, when researchers from the University of Texas at Austin looked at a particular species of tree, they were looking at the purple blooming Dipteryx oleifera on Barrow, Colorado Island in Panama. They found that the distance between an adult tree and its nearest neighbors is not what it's expected to be. 5.5 times farther than expected based on where a seed would fall, where it would go. And trees don't have the kinds of neighbors close in that you would kind of expect them to have. They're not close in. And so you're seeing these tree dispersal patterns happening at greater distances than all the things that researchers, ecologists of trees would understand related to forest ecology and how seeds would disperse and all of these kinds of things. And so they're like, why is there this huge distance between these adult trees and other adults of their same species? So we don't really know the answer to this, but they've used computational models. And so they determined that what's probably happening is that there are resources necessary for the sustainability of a particular tree. And a particular tree doesn't want necessarily competition from its offspring. And so there are other things that happen in the real forest, in how a forest actually works, to shape the forest and to lead the forest to be differently distributed than we would think it should be.
Is it going to be? I mean, the first thing I think of when you're saying this would have been the microbes in the soil. If the parent tree or the adult tree has somehow recruited the beneficial bacteria from a certain range through its root system over towards it, and left a sort of barren area out beyond. Except that one seems a little fishy. It almost would be like they would have to recruit unbeneficial bacteria at a perimeter or something that the tree could withstand, but a sapling might not be able to. But I would first look to the soil and study that soil around those trees to see what's going on there.
Yeah, so one idea is that it's not necessarily resource competition, but more survival from pathogens, and that by having greater distribution between a parent tree and an offspring, that the pathogens around trees are actually part of the system of making room. That a tree doesn't necessarily want its offspring nearby in case there's a pathogen that's going to take one of its kind down. If there's something nasty around, you don't want it to affect the entire community.
Yeah.
Anyway,
that's some high level thinking for a tree. I mean, I appreciate all living
trees.
Things
They're slow life.
Things.
Yeah, the slow life that doesn't run away from a predator, right? But they've made adaptations for the fact that they are more or less stationary in their lives.
Yeah.
But
and
it's
that's why, like,
Go ahead.
well, wait, so this is one of the things that invasive plants, for instance, are capable of doing, which is that they alter the microbial, or they come with a different microbial soil.
Yeah.
In any case, what happens is you have your native plants who, as these invasive plants are growing, they're creating this radius of a different biome in the soil.
Very
that
possible.
The native plant can't survive it. And so as you see an invasive plant take over, it might not be the plant is like such a fast grower or a good grower and it outgrows the other plants. It could be that it's affecting the soil in such a way that the other plants can't take advantage of it.
Yeah, and we do know that there are certain plants that you shouldn't plant together because one plant does actually kind of release signals or change the soil in a way that impacts the soil around it so that other plants can't survive. There are definite relationships between various plants within ecosystems. And so this is coming to that, looking at kind of this larger, not just your garden kind of perspective, but large forests, how ecosystems work, how if one tree is in a particular place and it allows other trees to grow around it, but its own kind to go further away, maybe that is beneficial to its survival. And maybe it does, maybe there is something going on with the microbiome. I don't know that. That's not what this study got to,
but it sounds like it's going through a change where it's affecting it over time, and the initial conditions it needs to grow don't match its later conditions. That's what it sounds like.
Yeah. So how does this impact species diversity in an ecosystem? How does it impact if you get rid of certain plants or trees through selective logging or other impacts? What is going to happen to the forest ecosystem as a whole? And so these are questions that this kind of research is going to help us potentially answer. So, understand what the trees want to live like. Speak to the trees, not for them. What do you want to talk about next, Justin?
Well, I got a paper titled The First Room Temperature Ambient Pressure Superconductor.
Which?
It wasn't.
Yeah.
Well, it might be. I don't know. South Korea's Quantum Energy Research Center made the claim via a archive preprint of discovering room temperature superconductivity, working at ambient pressure with a modified lead apatite, the now nerd famous LK99 material. This is a huge leap forward in material science and in electronics and computer packs. All sorts of things would be affected by this. But you have to look past apparently a sloppy preprint paper, a lack of reproducibility, already like a dozen attempts to recreate this with different research institutions. And the fact that some authors didn't agree with the release of the paper, something which South Korea apparently is investigating. And just skip past all that and just believe the future of superconductivity has arrived to social media.
To social media.
That's where it's really going to be happening, apparently. It's where all the physicists and material scientists have been hiding all this time. Apparently, though, there are some problems with the basic physics that have been pointed out. This is from an article in Science by Adrian Cho. Michael Norman, a theorist at Argonne National Laboratory, says they don't know much about superconductivity, and the way they've presented some of the data is fishy. You never want your peers.
That's a hit.
Yeah, that's the kindest way I think you could say that. They don't know much about what they're talking about, and their data is fishy.
Oh.
He goes on. Michael goes on to say that copper and lead atoms are similar enough that substituting copper atoms for some of the lead atoms in lead apatite shouldn't affect the material's electrical properties. He says you have a rock, and after the doping process they reported in affecting the material, you have a rock, but after you should still end up with a rock. You started with a rock, you'll end with a rock. Nadia Mason, a condensed matter physicist at University of Illinois, Urbana-Champaign, says, the data seems a bit sloppy. For example, when viewed in detail, key voltage versus current graphs do not show the telltale plunge straight to zero, which would indicate vanishing resistance. The paper also shows identical magnetic data in plots with incommensurate axes. So, I don't know how lazy you have to be to have a paper where you're reusing your data in graphs. But you see this quite a bit. I guess if you're too lazy to do the science, you're still too lazy to write the paper, the fake paper.
Hey, they wrote the paper.
Still, there's a chance that they've done it. After all, if I had created a superconductivity at room temperature, I might hesitate in publishing a paper and explain to everyone exactly how I managed it. I might head down to the patent office first, make some deals with some big companies, electronic companies for that. But then if I haven't published a paper, what are they believing when I'm trying to make these patent offices and these deals? Like, so I don't know. I think if I was not going to publish, I wouldn't publish a fake version of the paper. For sure. But it could not be it could be the real thing. It's just, it turns out it was never that hard. Interestingly, a dozen labs have tried to reproduce, and almost all of them have said, we're not getting this effect. There's a Chinese group that said, wow, we got superconductivity with this at negative 100 Kelvin, which is not room temperature.
Definitely not room temperature. Yeah. No.
You know, even when they're talking high temperature, you can be at negative 100 degrees.
The most recent other study related to room temperature superconductivity, room temperature was still in the serious negative kelvins. It wasn't really room temperature.
Yeah, and also like the last time, because we also discovered ambient superconductivity at ultra high pressures. And that paper also, I think, has been retracted because it turned out perhaps a lot of the data was fabricated.
Yep, that's true, actually. Yep.
Yeah.
Or misinterpreted.
Well, yeah. It could be. It could just be misinterpreted. Or it could be they did it as well, but want to keep it a secret. Like, stop. I'm starting to get this tabletop fusion vibe with anybody who's making any kinds of superconductivity, room temperature claims, pressure or not, you know.
It could happen eventually. We're going to figure it out eventually. I didn't bring this story last week specifically because I thought it might be fishy and I wanted to wait until there was more input on what had actually happened, and add that to the fact that it hadn't been peer reviewed and published in a major journal. It was on the archive preprint server. So it wasn't even a paper that had been, peer reviewed and published yet. And now that the peers are weighing in, we're seeing that it isn't adding up. It so far rules out superconductivity for this material. Potentially, there's still more work to be done to see what the properties of the material are and to see what can actually come out of it, right?
Yeah, I mean, if you believe the researchers, they have created something that can levitate magnetically. That is not. It's a property of superconductivity materials that can do that little levitation trick thing. But you can also get that without being superconductive. There's other, so it's not, they don't roll together necessarily. No. So maybe they found the one and then somebody on the team decided, hey, that's enough to get really famous with for a minute. But there's other authors on the study who apparently are saying we did not
to prove that.
permission to publish.
Yeah. So
That's a problem.
somebody hit the submit button a little early. That's probably someone got excited, published without all of the
be first. What if somebody else catches it and then we're not the first and then we don't get the Nobel Prize?
Yeah.
The Nobel Prize is pretty
could be
pretty luring.
It is. And also what would come from superconductivity at room temperature or higher temperatures is, you could have better batteries, no energy loss in energy transmission across the country. You have lots of applications that it could be used in. Currently, we use superconducting magnets in the Large Hadron Collider, but there's lots of potential for how it could change the way that we create the components of the technology that we use that consumes energy and transmits energy today.
Yeah, the first thing you'd want to do is use this material to convert all of the power lines in the world, because of the energy that we produce that is contributing heavily to global warming, half of it is lost before it gets used, before it gets to a house. It's all that resistance. We could cut our emissions from energy like almost in half, just with the material.
Yeah, so there's another study that's out this week that has actually been peer-reviewed and published in Physical Review Letters. This is not a discovery of room temperature superconductivity, but it is work in that direction into understanding how we might get there and even to higher temperature superconductivity. And so they have identified a mechanism that they report in this paper for oscillating superconductivity that's called pair density waves. And in this, they discovered, according to the researcher Luis Santos from Emory University, they discovered structures known as Van Hove singularities that produce the modulating, oscillating states of superconductivity. And because of this discovery, they now have a new theoretical framework that they can work forward from to understand how the oscillations occur, why they occur, because that's the important part in the quantum interactions in the superconductive materials, is that they start kind of behaving in a way that's not like classical physics, but also that they oscillate together so that the electrons are kind of working in this stabilized oscillation in synchrony. And it's the collective state that works to lead toward the superconductivity. And that's the important part. So the researchers, they're not saying that they've, discovered all sorts of stuff here, but they're theoretical physicists. And so they're trying to figure out how they can predict and classify the behavior so that applied physicists can lead toward stuff that has technological relevance. So, it's not the holy grail yet, but researchers are still working in different directions. They're explaining the mechanisms. Once we understand things better, that can lead us to making actual superconductivity at room temperature.
Just important safety tip.
Mm-hmm.
If you do discover the Holy Grail, that's the Ark of the Covenant.
That's the Ark of the Covenant. Don't open the box.
Don't open it.
We know that.
Don't open the box.
Oh, Indy. Yeah, Indy didn't open it, though. Let's see. And my last story for this first part of the show, University of Chicago researchers just published in Nature Physics their work into something called quantum superchemistry. It sounds pretty crazy, huh? Anyway, quantum superchemistry is a phenomenon where particles are in the same quantum state, and that allows them to undergo accelerated reactions. So kind of like a catalyst in a molecular reaction can speed up the reaction time that takes place. The fact that molecules or atoms are in the same quantum state can accelerate the speed of the reaction as well. In their work, they were able to cool down some cesium atoms and put them all in the same quantum state. And then look at them try to become molecules by binding to each other. And they found that they would collide. And normally, chemists can understand kind of like the thermodynamics of a situation to be able to give a probability of how many molecules will result in a certain amount of time if you have all of them in a particular normal state. However, when they have them in this quantum state where they're all kind of doing the spinning together in the same way, it's a similar kind of thing to the superconductivity, which I thought was very interesting. It's more collective. And they discovered that the more atoms in a system, the faster it happens even. And it's even better when you have like 3 atoms, cesium atoms, running into each other, because it's like the third one is left all by itself, but it somehow helps speed up the formation of a molecule by the other 2 atoms. So
just because it's stepping back and saying, "Oh, you two look great together." It's like
it's yenta, right? It's like you have a quantum chemical yenta in there. So here, what they're saying is that with the technique of using quantum states and producing a system where atoms are in a similar quantum state, you can steer the molecules that are produced into reacting in a particular way and in a faster amount of time. So they think it's going to hopefully allow researchers to handle larger, more complex molecules if they can figure out how to quantum engineer the molecules into similar states. Maybe this can be used in quantum computers, quantum information processing, the understanding the laws of how these fundamental interactions take place at the quantum level is this new area, quantum superchemistry. It's fantastic. It's super.
You know,
what? You sat there quietly. I was like, I'm gonna go.
There's this period where everything started getting called quantum something, whether it was or not. Oh, we got a quantum this, quantum that. Okay. And now superconductivity was in the news, and so they're like, oh, we'll call ours super. Anyway, yeah, go on to that. We have a super quantum break we have to take, I think, here. And then we're, right? We'll come back with more soon.
Oh, it is super. We're super glad you're here. We hope that you are a measurable quanta of human beings. We hope that your quantum state is oscillating in time with ours. Thank you for being with us for this episode of This Week in Science. If you are enjoying the show, please head over to TWIS.org and click on the Patreon button that will take you to our Patreon community. We are listener supported. Over at Patreon, you can choose your level of support, $10 and more a month, and you will be thanked on air at the end of the show. One of the producers, executive producers of the show. Thanks to you, we can do the show. And also, if you like the show, share it with others. Click that share button right now. Tell some other people about TWIS. We really can't do this show without you. Thank you for your support. Coming on back right now, we're going to go into Blair.
No. It's that favorite part of the show everybody loves. Justin's Animal Corner. With Justin.
Justin, yeah. Okay, what you got, Justin?
Yeah. Just like it's always been.
Always, forever and ever. Lies.
I have a lesson from the Animal Corner that should be taught to children everywhere. Researchers at the University of Lyon visited a zoo in Morocco with more than 300 Nile crocodiles. Clarify, the Nile crocodiles were already at the zoo. The researchers from Lyon did not
bring them to the zoo.
Nile crocodiles. The Nile crocodiles were already at the Zoo of Morocco. I feel like that might have been able to go by without explaining.
It's like from that. It's like from
just
that
to
Monty
clarify.
Monty Python Search for the Holy Grail. It's, I already got one. Anyway.
This researchers from Leon, this is their research. They do crocodile research, and they bring 300 crocodiles with them just to various places, see what happens. No. This is the Zoo of Morocco. They have 300 Nile crocodiles. The researchers set up loudspeakers alongside 4 of these big ponds where at any given moment you can look out and see a few dozen crocodiles sunbathing, waiting for hapless zoo goers to fall into the enclosure. The speakers that were set up blared out a series of cries from chimpanzee, bonobo, and human infants. And the researchers wanted to observe then the reactions of the crocodiles. Would they turn their heads? Would they just blink their eyes in acknowledgement? Would they acknowledge the sounds in any way? Many of the crocs did respond, rapidly seeking out the source of the cries, sometimes trying to bite the loudspeakers.
What?
The response, the number of crocodiles that they got to investigate, depended on the characteristics of the distress cries. Crocs were more likely to respond to recordings with highly upset infants than those that were just mildly upset. So, only 1 in 5 of the crocodiles responded to recordings of human infants experiencing low levels of distress. So, if you got a whiny kid, let him know only 1 out of 5 crocodiles are going to come looking for you if you keep that up. But
happy babies don't get eaten by crocodiles, honey.
Yeah, but that rose to 1/3 of the crocodiles if the cries were of severely distressed human babies. Now, these
That's going to be louder, though, right?
Well, so what's interesting, this is kind of an interesting aspect. It wasn't volume. And when they did this side piece where they had humans listen to the cries, and humans almost immediately associated the level of distress with the pitch. So the higher pitch it was, the more distressful humans rated it. But there's disparate patterns that the crocodiles were picking up on that was separate from the pitch, that is actually more identifiable as distress. So they're actually better at hearing distress in a human infant than most humans. So 1/3
because
of the cries,
distressed human infants at the edge of the waterways are I mean, I don't know. This is, you're stuck in the mud, you're crying, you're upset. Where's my mother? I don't know. And so then it's like, oh, easy pickings.
Yeah. If they were severely distressed, if they're throwing a fit. So they played, a third responded to the cries of severely distressed human babies. Now, these recordings were made of children at bath time or while getting vaccinated. So that's the normal course of everyday human baby life. So they weren't dangling babies over the side of the enclosure to get them distressed.
No, you said they were loudspeakers, that they had speakers in there that they were using to play.
No actual babies
were used
were harmed. And they doing this research. So so, if there is a crocodile in your area, maybe one lurking under the bed, maybe one hiding in the closet, throwing a tantrum is a sure way to get their attention. A quiet child, as Kiki's pointing out, is an uneaten by crocodile child. And I think that's what the study's trying to tell us. Although, to be fair, though, while it's possible that crocodiles have attuned their hearing to the distress calls of other species' infants. Now crocodile mothers do respond to distress calls from their own young. So a future research could look into the possibility that the crocodiles were actually racing to the loudspeakers out of concern, and biting them with their massive jaws is how crocodiles communicate care in dealing with infants.
Here, little baby crocodile, run inside my mouth. Don't they sometimes hold their babies in their mouths?
Oh, yeah.
They do.
Yeah,
So,
they do.
I mean, that's a real thing.
It could just be a bunch of crocodile. Well, except it was both male and female. I don't know how the roles. I think the male crocodile is the one that raises the young, if I'm not mistaken.
Yeah.
Actually,
So what we'd want to do is check this on different species of crocodiles. We'd want to maybe, I don't know. You have to figure out how to differentiate between whether or not this is maternal paternal care or attacking something that is in distress because it's an easy target. All right,
I think that's going to be what it was.
Yeah, but it's interesting. I like the frequency and the pitch aspect to this, and that this is something that they're listening. Crocodilians go back a really, really long time, and we know they have all sorts of complex behaviors. So you don't know. Need more study. More study.
But a good story also to keep the kids in line.
Oh my goodness.
All children need to know that they're attracting crocodiles.
When you're near the water, you better be good.
That human children are actually as noisy as they are.
And we've survived.
It just shows that we've been an apex predator for a long enough time, because I don't think that sort of behavior.
Or smart enough for the parents to, I mean, they're not necessarily, it's the apex predator part. It's just smart enough to get away in time or to protect ourselves, or there's lots of things that are in there. I am giving us the benefit of the doubt. Kind of. But I shouldn't, because we're going to leave the animal corner now, and you want to talk about something. What have we done to the planet, Justin?
Oh, it got ruined. So this is a study finds ocean currents that redistribute heat, cold, and precipitation between the tropics and the northernmost part of the Atlantic region. I think we call this the Conveyor Belt. North Atlantic Conveyor Belt, whatever. It's going to shut down around the year 2060. Maybe 2057. It'll stop working. This is suggesting a colder future may be in store for those unlucky enough to live in Northern Europe. Oh gosh, wait, that's where I am.
Right now.
The conclusion is based on new calculations from the University of Copenhagen that contradict the latest report from the IPCC, saying, yes, this is very likely to happen. In the new study, researchers from University of Copenhagen's Niels Bohr Institute and Department of Mathematical Sciences predicted that the system of ocean currents, which currently distribute cold and heat between North Atlantic regions and tropics, will completely stop if we continue to emit the same level of greenhouse gases as we do today. Using advanced statistical tools, which I'm glad they're using, because
instead of the old statistical tools.
The old statistical tools.
the very retro, not advanced, reverse evolution kind of statistics.
Yeah, those ones never turn out the way you think they should.
That's not what you think.
But with the advanced ones, and ocean temperature data from the last 150 years, researchers calculated that the ocean current, known as here's the thermohaline circulation of the Atlantic Meridional Overturning Circulation, AMOC, will collapse with 95% certainty between 2025 and 2095. With this most likely occurring, the peak advanced statistical prediction being in about 34 years or 2057, and could result in major challenges. Let's put it lightly. Particularly
Challenges.
okay,
That's fair.
increased storminess and cold in the North Atlantic region. Which no thanks. It's already plenty stormy here, but.
Maybe summer
Then-
would be cooler. You wouldn't be so hot in your apartment. Wouldn't
Yeah,
need AC anymore.
I guess that's possible. If it does stay cooler, that could be an okay silver lining, I guess. I feel like there's going to be ramifications further. Like, oh, yeah, the temperature will be fine, but the jet stream is going to move down to ground level. And there'll be a 140-mile-an-hour wind 24/7.
Yeah.
Oh, it won't be. So there's going to be... Okay, so meanwhile, all that heat that normally exchanges its way up north will likely remain in the tropics. With warmer waters in the tropics.
More hurricanes, maybe.
Oh,
or-
yeah.
Yeah.
So it's more hurricanes, higher intensity, certainly much more moisture that can be redistributed to what was once Florida and along the eastern seaboard of the United States.
Yeah. So, other reporting on this story that I've heard since it came out, many climatologists and researchers into atmospheric effects, they have wanted to really make sure that this is going to potentially affect the AMOC, the Atlantic meridional overturning current, but not necessarily the Gulf Stream. There's going to be heating down there, but it's not going to potentially really upset or change the Gulf Stream. So that, like you said, the jet stream, that might change, but because of the cooling,
hope
but
not.
yeah,
I was
but we
making
don't.
that one up. I hope
No, we
that
don't.
doesn't happen.
But we don't know. The only thing that right now this is just okay. It's going to be colder. That could have impacts in cooling and potential cooling effects over in Europe, Northern Europe. But and the other aspect of this is that the media has jumped on the 2025, which is a year and a half away. And that's not the likelihood. It is that's the outside edge of the error possibilities.
Well,
and so, like you repeated multiple times, this is later this century, but not outside of reason.
Not that much later.
Not that much later, when originally researchers and the IPCC have been probably after 2100.
Mhm.
So this is a shift. This should elicit a shift in the way that we think about things. I don't know if it's going to because of human psychology, but yeah, it's not going to be next year. But things are shifting because we keep making the oceans hotter. We keep making the atmosphere have more carbon dioxide, make it hotter. The pHs are changing in the ocean. Things are shifting. We got to do something.
So the thing to remember too is that this is do you remember the Winter Olympics that was held in Scotland? No.
No.
You don't.
No?
However, Glasgow, however you say it,
Is
is
Scotland?
as far north as Calgary,
Yes.
where there was a Winter Olympics.
Yes.
Right?
Yes.
London, I think, is equivalent to Juneau, Alaska, in terms of how far north it is. And Denmark.
It's hard. Yeah, it's hard to
forget
the
it.
way that things are projection mapped, right, and smushed on a
Well,
map. It's hard to
if you
hard
look
to.
at it, actually, if you look at it in a map, you can see it right away. It's actually not that hard if you have a map laid out. But
with
but
the latitude
we're
lines
not
that you're
used-
looking at.
Yeah,
But yeah.
if you follow the lines, it makes
You
perfect
follow
sense.
the lines,
It's not a mystery. The Earth is round, but you can still see how far north things are. But we're not used to conceptualizing things. I think, at least I'm
Yeah,
guilty
it's
of this.
hard.
Conceptualizing things that are colder as being further north. Places that are colder must be further north. That's how you get colder. But the whole European North Atlantic, northwestern European coastline is very far north. It's just not that hole because of these ocean currents, because of this circulation, because of this. And so if that stops,
the Vikings are going to come back, and the Vikings are going to just the Vikings with the furs and the horns and spears and the fighting. That's going to happen.
Yeah, well, it might be before the Vikings, because the last time I'm aware of, at least, that this happened was when we hit a kind of mini ice age. I think that was the younger Dryas.
Yeah. 8,000, 10,000, 12,000 years ago or so.
Like 12,000, something like that. Yeah. And it was a mini ice age that created one of the big near extinction events. But so maybe maybe we found the path of least resistance solution to global warming, which is if you do nothing, it ruins the ocean currents, and that causes snowball Earth for a little while, for
strife,
2,000 years.
I don't like that one. I don't like that. Choose your own adventure. I'm going to dog ear that page. Go back to where I'm going to try the other option.
What was that one?
It's the one where we actually do something and fix things and use our technology for the betterment. And
I think you and I can do that, but what about all the rest of the humans?
More sustainable, resilient systems.
Yeah, we could certainly do that, you and I. But what about the rest of humans? We still have to account for them, don't we?
Yeah, planet Earth equals Science Island at some point, hopefully. But we're all swimming in a sea of waves. We've talked about gravitational waves before. Justin, you wanted to talk about gravitational waves some more tonight?
I didn't really. I wanted to bring the story for you to talk about, but because I don't know where I've... Oh, here we go. So yeah, this is... Okay, so that sound that you've been hearing is not your tinnitus, and it's not the refrigerator humming. Apparently... that background hum in the Milky Way could be coming from binary black hole systems. There is these low-level gravitational waves that apparently they find permeating our galaxy. They think this is a researcher at UC Berkeley, Kelly. Where's Kelly's first name? Oh, I've lost it. Okay, well, I'm going to jump into their quote first, and I'll figure out who's saying this.
Luke Zoltan Kelly.
There we go. What a fantastic name. I guess the elephant in the room is that we're not 100% sure it's produced by supermassive black hole binaries. Okay. That is definitely our best guess, and it's fully consistent with the data, but we're not positive. If it is binaries, then it is the first time that we've actually confirmed that supermassive black hole binaries exist, which has been a huge puzzle for more than 50 years now. So, and where would we expect this to be? Where would our best chance for having supermassive black hole binary systems be? Sagittarius A, wouldn't it?
Right, we talked about that. Yeah,
you looked there and you didn't find it there, so it would have to be somewhere else in the galaxy. So now, like, if you have these radiating gravity waves, sort of low level, creating this background hum, I can't wait now for the scientists to figure out how to use that as a mapping system. Because now you have something that is pinging. If you can find sources, if you can identify where the sources are, and they're pinging, you may be able to get a map of our galaxy through those gravitational waves. I don't know. It's fascinating, interesting stuff to learn that even in the vast emptiness of space, you can still hear the refrigerator humming in the background. But that was it. That's all I got from the story. Making a humming sound could be supermassive black holes in a binary system found for the first time. Might not be.
But we need to do more study. But the exciting part of this is that they've used pulsars to do this as opposed to just the linear arrays that they have so far here on our planet. It's allowed us to see more and have better resolution.
Actually
Which is
using
exciting.
the pulsars as a detection device.
Yes. Which is so exciting.
Now our instruments are becoming the galaxy.
Yeah. Yeah. So they've got, the galactic timers, the oscillations. We're in the waves now, man. Swimming in the waves. But now that we have to navigate through our own universe, we always look back home to our own home planet, to little tiny things like butterflies.
Oh, little flutterbys. Yeah.
Little flutterbys. And we want to know, hey, butterflies, what you doing over there? How you doing over there? What's going on? And in this particular research published in Nature Communications this past week, published a while ago. July 7th. Researchers have determined that butterflies can navigate and they can remember the location of food sources. And I actually love this story because I've noticed in my backyard, sitting outside sometimes, or as I'm looking out the window at certain times of day, there is a particular yellow and black butterfly that seems to fly through our yard at very specific times of day, every day. And I found that very fascinating. I was like, wow, we're on like a butterfly little path. There's like a little butterfly hiking path right here, and that's what's going on. And I was like, that's interesting. And so to see this study come out, I think is really quite interesting, because these researchers were looking at the fact that these heliconian butterflies, heliconius, that they actually can learn all sorts of spatial stuff, and that their neural systems are really big enough and active enough to be able to learn the locations of various food sources. And they tested it a number of ways. One, just kind of giving them an array that was like a square meter across with a bunch of little fake flowers that they were like, do you know where the pollen is? And the butterflies are like, yeah, I can find the pollen, and I'm going to go back to the flowers with the pollen. And that's great. And so then the researchers said, okay, we'll give you a bigger space, and we're going to give you like a Y maze. So at the end of two arms, there are going to be two different sets of fake flowers that we've grouped with pollen or no pollen, and see which one you can go to. And the butterflies were like, I got this, no problem. 3 square meters, Y maze. I know what you're doing here. I can remember all of this stuff. And so the butterflies were remembering where that food was. And then the researchers also took a look at a much larger space to see how they were able to learn. And I love this. It's the Metatron in southern France. This was a 60-meter wide T maze. And they looked, and these were outdoor cages, not indoors. And it represented foraging between localities and approaching the scales that they think these heliconius butterflies might actually be foraging in the real world. And the heliconius butterflies were like, I got this. No problems. I can totally do this. I know what you're up to. I can remember these things. And so now they're looking at more long-term aspects, how long they can remember the information. And the butterflies are actually able to remember very, over a fairly decent 8-day, over a week period of time, which is very exciting. And looking at the spatial structures that exist within the brain of the butterfly, they say that there are definitely neural pathways and structures that are larger than they might be in other non-pollen feeding butterflies, or butterflies that don't do the same kind of spatial behaviors that these heliconius do. So the exciting part of this is that we know bees can do all sorts of cool spatial stuff. We know hummingbirds can, we know mammals can, but now this is the first species of butterfly that has been shown to have some kind of spatial memory and learning that is not just basic, but a little bit more complex.
Well, okay, so push back.
Yes,
I'm
please
gonna push
do.
back on this story.
Okay.
Painted ladies.
Yes, there are butterflies that migrate, right? So
they're butterflies that migrate, and what's wild about those migrations is that they will summer in the south of France and winter in some place in Central Africa, and that yearly migration of going to the same places that have the same plants that they can eat and have the same pollen, what have you. When a butterfly migrates over a year, that's not just memory.
Well,
that's generational.
Yeah, so that's what we call instinct.
That can be 5, 6, 7, 8 generations of butterflies. The ones that summer in France are not the ones wintering in Africa, right? Like there's like this. So there's something I would love to.
Yes, I was going to say this. So this is different. So this is a shorter term memory. This isn't that instinctual drive to go a particular direction and end up in a particular place for mating. This is even more than just specifically honing in on a particular looking flower. This is more. This is a more complex, shorter term, survival based foraging strategy. There's a foraging strategy for sure, but they're showing that there is memory and learning taking place. So it's probably more than instinct. They have a lot more tests that they need to do to understand how the butterflies are doing it and what they're doing. But
when you say something is more than instinct, and you're talking about something that is a globe trotter that finds the same locations, I mean that's so. What I'm curious though is because what I would call genetic memory. You're calling instinct. I'm calling genetic memory in the painted ladies.
Fair enough.
I wonder if that is taking place at all with these butterflies. Like if you took the offspring of these butterflies and showed them those tests for the first time, showed them those enclosures for the first time, I would be fascinated to see whether or not they figured it out right away or had to relearn it.
Yeah, and I think that's a great question, but because this is of course just looking at one generation of the butterflies, but what they suggest from the study is that there is an expansion of the visual processing areas in these butterflies, and this coincides with a good long-term memory. And they also think that this is what they would call selection for behavioral innovation, which would not be genetic memory necessarily or instinct, but the ability to adapt to new situations for foraging and to be able to learn what's going on in there. So of course there's going to be genetics in there somewhere, that are, some individuals are going to be better than others, but the question as to, what's going on in the brain, how much is being remembered, what they're looking at specifically, what's going on.
Wait a second.
Yeah.
You know what this unlocks? We can now, like we've talked about in the past, start a butterfly circus. we can train them.
Come to my butterfly circus. Yes, my butterflies will remember the food that we
can train them to jump through hoops or fly through hoops. I guess they would be terrible jumpers, but they're great flyers.
Mm-hmm. Do they tag butterflies? I think if they have small enough tags and big enough butterflies, they can. I'm not exactly sure about that, Lemodan. That's a very interesting question because that could also allow for more naturalistic investigations to take place so that they're not in a lab or in a cage situation with these kinds of questions. A lot of things to open up about what and how the insect brain works. My last story for the night comes out of the Hebrew University of Jerusalem, with groups from HUJI, Weizmann, and IST Austria. Researchers have published in the Proceedings of the National Academy of Sciences their work looking at how nuclear spin, so the up or the down nuclear spin of an atom, or we talk about particular nuclear spin when magnetic resonance technology is in place for brain scanning or for organ scanning. Magnetic resonance technology is in use when we have certain we can cause polarization of water molecules or oxygen molecules or isotopes, so that they're all kind of oriented in one direction or another, and that allows us to see how blood flows through an organ or how cells are placed. It allows us to do some really interesting imaging work at small scales. These researchers asked the question whether or not that spin of an atom impacts how it interacts with biological structures and biological functions. And so the idea being, how does, say, oxygen with a spin, because it's a particular isotope, oxygen 16, 17, or 18, is the spin different enough because of the fact that it has a slightly different mass at its center? Is that difference enough to change the way that, say, oxygen interacts with a pore in a cell membrane or with another molecule that is doing a metabolic function? How does nuclear spin of an atom impact biological functions? The researchers say that they showed specifically that these stable oxygen isotopes that they looked at, oxygen 16, 17, and 18, that the nuclear spin is slightly different. And yes, they interact with stuff differently. They say their research demonstrates that nuclear spin plays a crucial role in biological processes, suggesting that manipulation could lead to different applications in biotechnology. Quantum biology could revolutionize fields like nuclear magnetic resonance technology for our imaging. There's all sorts of stuff. Researchers have been studying kind of strange behaviors of particles in living things and trying to figure out why they work particular ways. And they say that this link between chirality, or their spin, and the mechanics, the quantum mechanics, that chiral molecules can be spinning differently, interact differently, and that it can change the way that biological processes occur. The weird thing,
we were all quantum beings all along.
Yeah.
We didn't even,
we could be, it could be a new way to treat illnesses. But the one thing that I think is strange is this does influence how water behaves in cells. And so does this mean that the people who have been talking about their like special ionized water or whatever and the health benefits of it,
I still have no idea what they're talking about.
What, is it kind of right in a certain way? Like, does it impact the way that water enters a cell, or that it impacts molecules and the different chiral molecules involved? I'm not saying it does. I am not supporting this because the research has not been done, but it opens up a lot of questions in there. Quantum. Yes. Spin. I'm spinning out of control. I think we're spinning towards the end of the show. Have we done it, Justin?
Yeah, I think we got a tight 90. Look at that.
Look at that.
That's how you do it.
Woo, woo, woo. We've made it to the end. You've made it to the end with us. Thank you for joining us for another episode of This Week in Science. It's time now for me to say thank you to all of you in the chat room, over there in our Discord. Heyo, thanks for talking. Thanks for your comments. Thanks for your questions and input. I love the fact that the conversation can happen while we're doing the show. It's just fantastic. Fada, thank you for your help with show notes and social media. Identity 4, thank you for recording the show. Gord, Arnlore, others who help keep the chat rooms safe places to be, thank you for your work in that. And Rachel, thank you for your help editing the show. And finally, many, many thanks to our Patreon sponsors, without whom we would probably not be able to do this at all. So thank you to Arthur Kepler, Craig Potts, Marie Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, Rick Loveman, George Corris, Pierre Velazarb, John Ratnaswamy, Carl Kornfeld, Chris Wozniak, Vegard Chefstad, Donathan Stiles, a.k.a. Don Stylo, Ali Coffin, Reagan, Sarah Forfar, Don Mundus, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paulo Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Johnny Gridley, Remy Day, Jean Burton, Lattimore, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkan, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you for all of your support on Patreon. And if any of you out there are interested in helping to support this show, head over to twist.org and click on that Patreon link. On next week's show,
we will be back Wednesday at 8 p.m. Pacific time. And a second show that we do is on Thursday, 5 a.m. Central European time.
Why are you
We'll be broadcasting live from our YouTube and our Facebook channels and from twist.org/live.
Yeah, want to listen to us as a podcast? I know you do. Just search for This Week in Science wherever podcasts are found. And if you love this show, get your friends to subscribe too.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twist.org. Where maybe you can sign up for a newsletter. I'm not actually sure.
You could do that. You can sign up for it for sure. You can also contact us directly. You can email me, Kirsten, at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org, or just put, or actually, no, you actually need to put twists in the subject line so your email doesn't get spam filtered into a binary black hole where maybe we can't even find it because it doesn't even exist at the center of our galaxy.
We love your feedback. If there's a subject you would like us to cover or address, a suggestion for an interview, a haiku that comes due tonight, please let us know.
And we'll be back here next week. We hope that you will join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.